Welcome back, calculus students. This is a third video we uploaded in lieu of today's class, but anyone watching may want to review using a quotient rule to differentiate a composition. So we're going to look, mainly we're going to look at this right hand side, and we'll differentiate this function, which is a quotient, all raised to the 8th power. Now in the previous video, if you look back, we found the derivative of just the quotient 2x minus 3 over 4 minus 5x. We recall that and I should label this f prime of x, the derivative of that original function has almost the same denominator, except it's the original denominator squared. And after we did some simplification, the numerator simplified way down. Some linear terms canceled and we came up with a -7, and we made some further conclusions. But for this part of the video, and we're about 1 minute in now, we're going to look at a related function and find its derivative using the chain rule. Okay, so let's just call this function w. We have a linear function divided by a different linear expression, all to the 8th power. Okay. Now, for some of us, let's see if we would like to recognize that this is essentially a power function where the base, which we might call u, the base is this ratio. And we know from the previous video, and you can pause the video here and reestablish this fact, but the derivative of u is going to be -7 over the square of the difference, 4 minus 5x. Okay, so we're about to do the chain rule. We haven't yet differentiated the entire function w. We've simply recognized that w would have been a power function, something to the 8th power, and we're now thinking of that. We're kind of thinking of w as u to the 8th, where u is that ratio. Okay. What do I want to say now? Well, I don't know that we have to call that w. It's just the output y. We can take the derivative of y, the power function, take its derivative with respect to u, bring down the 8, subtract 1 from the old exponent. So we're using the power rule on the outer operation of our composition function. Okay, so putting this all together, our derivative of w is going to end up being the product du dx times dy du. There's a memory aid here. It looks like the du's cancel, and it kind of looks like we just have dy over dx, just another way to talk about the derivative. So we look to the left. Our derivative here was -7 over 4 minus 5x, the quantity squared. We're going to multiply that times 8 u to the 7th. But we need to replace u with the ratio for which it was taking the place. Okay, so we still have -7 over 4 minus 5x, the quantity squared. We still need to multiply by 8 over 1. And now I'm going to replace the u with the quotient it was taking the place of. So that's the quotient 2x minus 3 over 4 minus 5x, all raised to the 7th. Okay. That's not a friendly answer, but that is a correct output formula for w prime. Okay. Okay, so since we're moving to another piece of paper, let me remind ourselves. We started with w of x, the quotient from the previous video, but this time raised to the 8th power, and we're about to simplify our work from above. Okay. Now let's take all those scalar coefficients. Let's note that there's a negative 7 and there's an 8. So I have a coefficient of negative 56 that we can write somehow. And then let's take inventory. On the end here I have 7 factors of the numerator. I have 7 factors of this denominator. But there's an additional 2 factors of 4 minus 5x. So in total, in the denominator, I take the 7 factors of the difference and I put them together with 2 more factors of that difference for a total of 9. And then I need to write down the 7 factors of 2x minus 3 from the numerator. We don't have to have the 1 in the denominator here. We do have to have the negative. But w prime is negative 56 times 7 factors of 2x minus 3, all divided by 9 factors of 4 minus 5x. Okay, that's about the friendliest way to write that answer. Thanks.